Hello everyone, in this video we are going to learn about AC waveform and AC circuit theory. This is our first video on this AC circuit analysis. AC circuit and waveform. So here is a basic circuit diagram of the lamp connection. In this lamp connection you can see that this is a AC source. So this is a AC source. Because of this AC source, we are getting at the output pure sinusoidal wave. At the output wave, we are getting pure sinusoidal wave. Okay, I am asking you why we are getting this pure sinusoidal wave. Because we are using AC source. Okay, if we use different types of sources as voltage source, we will get the different types of waveforms. For an example, if we use DC source as our supply, we will get a waveform, output waveform, something like this. So depend on the source we are using, we will get the different types of wave pattern. AC waveform characteristic. Under this topic, we have to analyze three different important parameters. So the first one is the period or the periodic time. The second one is the frequency. Third one is the amplitude. What is the periodic time mean? The periodic time is the length of time in seconds that the waveform takes to repeat itself from start to finish. For an example, this is a pure sinusoidal wave. So in this wave, you can see that this is the starting point. From this point to this point, it is increasing. Then from this point to this point, it is reducing to 0. Then after again increasing, then reducing. So this is a unique wave pattern. So in this wave pattern, you can see that the period time is the time difference in between starting point to end point. So from this point is the starting point. This is the end point. So from these 2 points we are considering as the periodic time, or if you consider the pulse wave, pulse width, we can call as the pulse width. The second parameter is the frequency. Frequency is the number of times the waveform repeats itself within a 1 second time of period. So within 1 second, how many time it is repeating means frequency. For the frequency, there is a common equation is the frequency will give the reciprocal value of the periodic time. So this is what I mentioned here. The frequency f will be equal to the reciprocal value of the periodic time. Or another way we can take as the periodic time will be the reciprocal value of the frequency. Another way we can express like this. The third one is the amplitude. The amplitude is the magnitude or intensity of the signal waveform measured in volts or amperes. So the amplitude means the point, the peak value from the start point to the peak point. Here this value we are calling as the amplitude. Types of periodic waveform. So here are some different types of wave patterns. The first one is sine wave or the pure sinusoidal wave. So you can see that here the y-axis represents the amplitude and the x-axis represents the time. Likewise, the second one is complex wave pattern. And the third one is triangular wave. Finally, the fourth one is square wave, or another way we can call as pulse. Relationship between frequency and periodic time. There is a common equation to find out the frequency. So here the frequency will be equal to the reciprocal value of the periodic time, which means f will be equal to 1 over t. The unit of the frequency is hertz. Likewise, if you want to find the periodic time, from this basic equation we can take out the periodic time into one side of this equation and other parameters to the other side of the equation. Then we will get the equation like this. T will be the reciprocal value of the frequency. T will be equal to the reciprocal value of the frequency, which means T equal to 1 over F. So the unit is seconds. So here is an example question. Example number 1. The first part is what will be the periodic time of 50 Hz waveform, and the second part is what is the frequency of an AC waveform that has a periodic time of 10 milliseconds. It is very basic question. So the solution is, the first part they are asking the periodic time. So as we all know, the periodic time will be the reciprocal value of the frequency. So this is the basic equation. So now we can substitute for the frequency. The frequency value is 50 Hz. So the 1 over 50 will be equal to 0.02 second. Or another way we can write as 20 millisecond. Now the second part, they are asking what is the frequency of an AC waveform that has a periodic time of 10 milliseconds. Now we have to find the frequency. So the frequency F will be the reciprocal value of the periodic time. So the periodic time is 10 millisecond. 10 millisecond means 10 into 10 to the power minus 3 second. So if you solve this, we will get the value 100 Hz. So this is the answer for this question. Average value of a non-sinusoidal waveform. Now let's learn about how to calculate the average value. What is the average value mean? Here, this is a non-sinusoidal waveform. So here this one is positive half cycle and this one is the negative half cycle. In the positive half cycle there is a maximum value. At this point it is lying a maximum value. So it is in the positive half cycle region. That's why we are calling as the positive peak point. Likewise this point we are calling as the negative peak value or the negative peak point. So now let's see about what is average value. To find the average value of the waveform, we need to calculate the area underneath the waveform using the mid-ordinate rule. The approximate area under any irregular waveform can be easily found by simply using the mid-ordinate rule. So here this area we have marked as V1. This one we have marked as V2 and V3, V4, V5. Likewise from V0 to V9. So the voltage lying in between VAVG. The average voltage will be equal to addition of all the voltage values. V1 plus okay, here there is no V0 is 0. Therefore, we don't need to put the V0. Here, the value of the V0 is 0. Therefore, we can omit that. So, V1 plus V2 plus V3 plus V4. So on till V9. Then we need to divide it by the number of segments. Here there are 9 segments. Therefore, we have to divide it by 9. So then after we will get the average value. So from this non-sinusoidal waveform, that average value will lie at this point. Average value or mean value. Another word we can call as mean value of an AC waveform. As I explained earlier, from this basic equation we can simply find the average value. So here there is a key point. For a pure sinusoidal waveform, mark this word, for a pure sinusoidal waveform, the average or mean value can be calculated by using this equation. Okay, I will explain you how to take this equation. So VAVG, to find the average value for a pure sinusoidal waveform, there is an equation. VAVG equal to 2 times of V maximum over pi. So that will be equal to 0.637 into V maximum. VM mean V maximum. Here also VM mean V maximum. So from this equation we can simply find the average value or the mean value. The RMS value of an AC waveform. The RMS mean root mean square. To find the RMS value, here this is the equation. From this equation we can find the RMS value for any AC waveform. So the equation is VRMS equal to square root of V1 square plus V2 square plus V3 square, so on till Vn square divided by n times. So here for the pure sinusoidal wave, to find the RMS value, there is an equation. VRMS will be equal to V maximum divided by root 2. So that will be equal to 0.707 into V max. So from this equation simply we can find the RMS value for any sinusoidal waveform. Any other AC waveform we can directly use this equation. Form factor and crest factor. Form factor and the crest factors are most important factors which is used to determine the shape of the AC waveform. So here to find the form factor, this is the equation. The form factor will be equal to RMS value over average value, which means form factor is the ratio between the average value and the RMS value. Likewise, we can find the crest factor also. The crest factor will be the ratio between peak value over RMS value. So these two factors are used to determine the shape of the AC waveform. For an example, there are so many AC waveforms. So initially I am going to consider the pure sinusoidal waveform. For the pure sinusoidal waveform, the form factor and the crest factor will be constant. Okay, I will show you here to find the form factor for the pure sinusoidal waveform. Here for the RMS value we can substitute 0.707 into Vmax, and the average value we can substitute 0.637 into Vmax. Then after here Vmax and Vmax will be cancelled. Here that will be equal to 1.11. So the pure sinusoidal waveform, we will get the value for the form factor as 1.11. That is constant. For all the pure sinusoidal waveform it will be 1.11. Likewise, for all the pure sinusoidal waveform, the crest factor will be here. For the peak value we can substitute V maximum. For the RMS value we can write as 0.707 into Vmax. Then here Vmax will be cancelled. Here that will be equal to 1 over 0.707. So if you solve that, we will get the value 1.4 0.14. So this is the value for the crest factor of pure sinusoidal waveform. This one is also constant. Example number 2. A sinusoidal alternating current of 6 amperes is flowing through a resistance of 40 ohm. Calculate the average voltage and the peak voltage of the supply. So let's mark the data. Here the value of the current is 6 amperes. And the resistance is 40 ohm. And here a sinusoidal alternating current, which means a sinusoidal AC supply. So here for the sinusoidal AC, the form factor will be constant. Form factor and the crest factor will be constant. Form factor will be equal to 1.11 and the crest factor CF will be 1.414. So those two values will be constant for all the pure sinusoidal wave. So now we can simply do the calculation part. So the question is, we have to calculate the average voltage. So before to calculate the average voltage, let's find the RMS value. RMS will be equal to I into R. So now we can substitute for the I 6 ampere, R 40 ohm. So altogether that will be 240 voltage. So this is the RMS value. So our question is, we have to find the average voltage. So to find the average voltage, we can take another relationship for the form factor. Form factor is the ratio between VRMS over V average, VAVG. So from this equation you can see that we know the value for the form factor and even we know the RMS voltage value. Now we need to find the average voltage. So from this equation VAVG will be, average voltage will be equal to VRMS over form factor. Form factor I can write as FF. So VRMS is 240 voltage and form factor is also constant, which is 1.11. So that will be equal to, if we solve this, we will get the value 216.2 voltage. 216.2 voltage. And the second part is we have to find the peak voltage of the supply. To find the peak voltage of the supply, we can use another relationship for the crest factor. The crest factor will be equal to V maximum over, crest factor will be equal to V maximum over RMS value, VRMS. So this is a sinusoidal AC supply, pure sinusoidal waveform. So for the pure sinusoidal waveform, the crest factor will be constant, 1.414, and we know the RMS value. Now what we need is, we need the peak value, or peak value means the maximum voltage. So the V maximum will be equal to crest factor into VRMS. Now the crest factor is constant 1.414. 1.414 into RMS value is 240 voltage. 240. If we solve this, we will get the value 339.4 volts. So this is the answer for this question.